Good morning, everyone. Good morning. Good morning. Good morning, Jennifer.
Good morning, Pete.
Yeah. Wow. We're here for episode 2 of Edge AI Solutions. And
Yeah, thank you for having us.
yeah, no, great to have you. And boy, it's going to be quite a solution we're going to talk about today. A very timely topic around, I think we've entitled it AI on the Roof, but really about using Edge AI in HVAC systems and things like that. So it's going to be pretty cool. Pretty cool.
We hope it's cool.
Yeah, I was going to say there's all kinds of puns we could say. It's a hot topic. Right. It's going to be cool. Okay, we'll get those out of the way early on. But welcome, folks. This is a live stream, and so you're going to be able to ask questions of Tracy Markie. I'm sorry, our expert guest, and so please do so and chime in on the stuff here, whether you're on YouTube or LinkedIn or Twitch or Facebook or now Substack. We are meeting you where you're at in terms of helping you understand the impact of Edge AI and some of this stuff. I'm just going to read off some folks here. There's let's see. Okay, let me get the name right. Pathmanathan is dialing in from Malaysia. It's 11 p.m. in Malaysia. Good to know. We also have someone from Bellevue, Washington, so that's good. Kind of a local. Christian from Bremen, Germany. Excellent. Kind of probably late afternoon there, I'm guessing. I'm trying to guess my time zones. But yeah, we'll have lots of folks on board here to talk about things. Anything new with you, Jennifer, that we should know about? What's happening? How's the summer?
Well, I'm enjoying the week in Phoenix, and we've had some interesting weather here this week. So I've experienced my first dust storm. I think that one is enough, but yes. And how about you?
Well, I'm in the Pacific Northwest, so I'm actually blessed right now with some amazing weather. Speaking of weather, so I was in, we had a big event, Edge AI London, about a few weeks ago, and the weather was pretty cool there, literally. And then we went to France for a week, and it started to get super hot. And we were just talking before the show about kind of this. There's an interesting, I don't know if it's a cultural thing or whatever, about air conditioning and in Western Europe, at least, probably Eastern Europe as well. And also, when you order water in France or in Europe, they don't put ice in the water. So there's a whole thing going on over there. But yeah, there's parts of the world now that can really use some climate control. But yeah, Pacific Northwest it's fantastic. So if people don't know, they think it's all rainy here all the time. The summer is actually like 75 to 80 degrees and kind of sunny, and it's very nice. So I feel blessed, and I will definitely spend some time outside today, which is good. I see we have someone from Louisville, Kentucky. Cal, awesome. We have Christian also from Germany, and yeah, lots of folks coming in, so that's good. Maybe we should bring on Tracy and get the party started.
Sounds great.
And let's see where he's at here. Tracy, welcome.
Good morning. How are you?
Good. Yeah. And where are you connecting in from?
I also am in the Phoenix area in Chandler, Arizona. And Chandler. It is hot, appropriately themed location for today's topic, for sure.
Yeah. Well, and Chandler is a very famous area for the semiconductor industry as well. I mean, Avnet has a facility there, but there's Intel, Chandler. I believe Microchip is there.
Microchip, yep.
NXP.
NXP is there.
NXP is here. A number of data centers. I can walk to about 5 different data centers from my house in less than 20 minutes. Wow. So, yeah.
That's probably not something you could have said a few years ago, but
yeah, the growth here has been explosive. We're on the edge of one of the high-tech kind of areas where I live, and it's just incredible how much growth there's been down there. So
yeah. No, I went down there. I think I visited Intel and Microchip. I think it was about a year ago. And yeah, around 7 a.m. was kind of like my breaking point in terms of temperature. I was like, everything past that, I was like, it's too hot here.
Yeah, I don't know if you're a golfer, but you want to be on and off the course by 8 or 9 in the morning if you can.
Yeah.
It starts getting interesting after that.
I see we have Klaus from Switzerland here, Idris from Nigeria. I'm not going to guess on time zones, but yeah, great to see the crowd here gathering. And yeah, so tell us what you're going to tell us about. What's the hot topic today?
Well, today we're going to talk a little bit about our platform and how we sort of evolved into where we are today. Before I even talk about Edge AI, probably helps to understand why we ended up here.
Okay.
Engenuity, just for the sake of background, it's been in the building automation, energy management space for a little over 30 years now. For the last 15 years, we've been focused on a problem that most of the industry kind of overlooked. And that specifically is, how do we make small commercial buildings smarter in a way that's, affordable, economical for the owners, repeatable, and then resilient. And that word resilient will come up a few times today, I think. Right. So, when people hear Edge AI, they usually think that's where the story starts. And, we were far from that. When we started this whole thing, there was no such thing as Edge AI, right? So when we started with restaurants, initially quick serve restaurants, expanded into convenience stores, then retail stores, and eventually kind of all types of more small, medium-sized commercial buildings.
Right.
They all have the same HVAC and energy challenges as large buildings, but none of them have facility staff. There's no IT people to help them out. Their capital budgets and maintenance budgets are much smaller than a large, let's say, university facility or something like that. And the problem was traditional building automation just didn't scale properly. And in this case, I mean, kind of scaled down, not scaled up, right?
Right.
So we really didn't start with building AI. We started with, building a platform that could reliably connect and manage these buildings. And specifically, we're focused on the HVAC part today. But we do lighting and walk-in and so forth too.
And you're the founder of Engenuity. How long have you guys been?
I am. A little over 32 years.
Wow.
So, yeah, we started in June of 94 originally.
Nice.
So
1994. There's a good song by Stephen Wilson called 1994.
And I am an alumni of Intel here you mentioned. That's why I got to Arizona to begin with. So
fantastic. Okay. So you're into it. Okay. Well, why don't we bring up your deck to kind of give some visuals, and then Jennifer and I will sort of fade into the background, but I'm going to encourage people to tee up some questions as Tracy's talking, and then we'll take some breaks along the way and have him address those. And Jennifer, any comments before we give Tracy the floor?
Yeah, well, we're happy to jump right in here. I'm really, when we talk about energy management and the SMB, market focus, Tracy, it's really impressive. And I think, just looking at the scale of the opportunity here, numbers are pretty staggering. So can you walk us a little bit more through even just the market size? And you already talked a little bit about it being some of the challenges, but why do you think that market has been so underserved?
Yeah, it's interesting. When we got into this, there were a number of attempts to kind of service this market that just failed miserably. I mean, kind of on the slide here shows a little bit. There's about 6 million commercial buildings in the U.S., and a little over 70% of them are actually under 10,000 square feet, and half of them are under 5,000 square feet. So in terms of just raw number of locations and buildings, SMBs far outweigh the larger buildings, but the larger buildings are a better match for larger providers of solutions, right? So that leaves a lot of room for innovation and technology to be applied in those SMBs. What our philosophy has been on this is, we're not replacing the controls or the buildings, obviously. millions of buildings here, but we're trying to make the buildings that already exist smarter. So, we set out to create, that solution for small, medium-sized buildings that was economical, but still had the feature set and capabilities of a large building automation system.
Yeah. And most of those buildings today are just controlled with a basic thermostat, correct?
Yeah, for the most part, the wide majority,
Yeah.
their HVAC controls, it's all done with just a thermostat. And most of those thermostats are not smart thermostats even. They're not connected to the internet necessarily. Over the past, let's say 3 or 4 years, things have gotten better from that standpoint. Many more smart thermostats out there than when we first got into this, but still largely underserved from a controls standpoint.
Yeah. And can you tell us a little bit more about what's actually happening in those HVAC systems, where the problems arise and how they're handled today?
Sure. So the one thing to start with is to know that most of these commercial buildings, including the building we're in our office, we're in a 16,000 square foot commercial building. The HVAC equipment there are called rooftop units, or RTUs. And the thing to know about RTUs is most RTUs don't fail suddenly. They do what I would call a quiet failure, right? Sometimes they're unnoticed unless it's the only unit in the building, but often a unit can fail and the surrounding units can make up for that, right? So they fail quietly. The other thing to note here is there's either no operational data, i.e. the, kind of plain old thermostat sort of controls, or if there is data, the data is trapped in a proprietary silo of some kind, or going somewhere where nobody really does much with it. Occasionally somebody might take a look. And most importantly, the data and information that's needed never reaches the technician in a way that they can do something with that information, right? Owners typically learn about the problems only after a complete failure, and there's a comfort issue, and that's affecting customers or guests or whatever it might be.
Yeah. So the problem is well underway before anyone notices or starts to take action,
Yeah.
which I can imagine is very problematic.
It is,
and
but it's also key to our solution we'll talk about here in a minute too.
Perfect. And I guess it sounds like this isn't a new problem, right? It's existed for quite some time, and there's clearly a lot of engineers working in the HVAC world. Are there things that people have tried that haven't worked in the past? What are things that you've tried and how have evolved?
Yeah, I mean, we didn't think of this problem or the solution off the top of our head, in the clear blue sky kind of thing. We were actually involved with a very large restaurant chain that had been trying to find a solution for a number of years. And once we got in and started working with them, we understood what the problem was. And the problem was they were trying to take a system designed for a very large commercial building and shrink it down to small building size. But small buildings are different than big buildings in a lot of ways, and the owners and operators of those businesses that exist in those buildings, the economics are different. They're under a lot tighter constraints. So the big building systems price point was too high, the payback was too high. So inevitably the ROI on any investment into something like this just wasn't there in a timely manner.
Yeah, and I think that's really key, right? It's not just about connecting the equipment, but it's about where does the intelligence live in the system. So I think that brings us to talk a little bit more specifically about what product you've built.
Yeah. Our philosophy on this has always been a couple of core things. One, keep it as simple as we possibly can. I created what we call the 20/20 rule when we were designing our platform, meaning I had to be able to teach a 20-year-old restaurant worker how to use this system in 20 minutes or less with no documentation, right? So everything had to be kept very simple. That was kind of philosophy number one. Philosophy number two was push as much intelligence as possible to the endpoint that was out there, whether that was a thermostat or a lighting controller, refrigeration controller. So pushing that intelligence, when we first started, this was called distributed control. It wasn't called edge intelligence. It was a completely different term, but that philosophy has remained consistent through all the years of doing this, right?
Okay.
So, we connected the equipment, we normalized the data, and then we take that data and now we are doing something with it at scale and presenting that back to a technician in a way that they can actually do something to help maintain these units out there.
Yeah, very interesting, which is a great transition to talk a little bit more about that technical implementation. Can you walk us through at a high level the architecture and even speak to maybe how your architecture has evolved over time as new technology continues to become available to help you improve your systems?
Sure. So the platform we're talking about today is generation 6 of our platform. When we first started, it wasn't even connected to the internet or anything. It was all on-prem. One of the key problems and challenges in working in the SMBs, and in particular in restaurants where we got started, is connectivity. Connectivity was a privilege back in the day, and quite often was taken out or just gone for anywhere from a minute to sometimes a month, right? So our original architecture was all on-prem. We controlled HVAC, refrigeration, lighting. Heat exchangers is a new thing that we've started to get into, but we kind of those core things that any small building might have. Refrigeration was a bit of a differentiator because of where we started, not so much in a regular office building, obviously. But if you think of things like pharmacies and convenience stores and grocery stores, along with restaurants, there's a lot of refrigeration out there as well. So we started with an on-prem architecture. It was always networked together to a central device and then served up a user interface right there on-prem. Eventually, that evolved to where we were connected to the internet and we were collecting data, and we created a user interface that allowed customers to get on and take control of their system, even remotely. So during COVID, for instance, that was a blessing. We thought we were going to lose customers because we were working in that restaurant space, and we all remember how hard that was hit. But actually, we didn't lose any customers during COVID. In fact, many of our customers, reached out to say, I am so happy we had this remote access because nobody was in the restaurants. They had inventory in their walk-in refrigeration units, needed to know whether their buildings were being kept at proper temperatures and so forth. And that was all done remotely. So that was kind of the genesis of that, and a kind of a validation of our early philosophy of pushing all of the intelligence to the end.
Yeah. Tracy, I had a quick question. Actually, we had a question here from Michael, which was kind of partially answered, but you mentioned before about, skilling and HVAC trade skills required for automation and edge AI, which is kind of related to my own question too, about how much of your work is sort of brownfield retrofitting intelligence into systems, or are these kinds of systems, are you finding that they really need to be more greenfield, like new equipment installations? Like, how does that work?
Great question. And I should have been clearer earlier on that, actually. So no, this is for existing and new construction buildings for sure. This is completely retrofittable into existing systems. A typical, if we went into a building that was, let's say, in its lowest level of technical advanced state,
Sure.
Dumb thermostats, no controls. The worst thing that we're doing is installing smart thermostats that are connected, installing a connected, intelligent refrigeration controller, and then adding, lighting control and intelligent IO controller to turn lights on and off, right? So very much the requirement when we started had to be retrofitted. Again, our original customer that we worked with that was behind this has locations worldwide. So, and we had to be able to work in any of those locations existing. And at the same time, they were building, hundreds of new sites each year. Right. So that was all an important part of it as well.
So so the intelligence that you have on-prem is really embodied in this kind of a gateway device that's collecting I would say the legacy signals from some of this equipment.
Yeah.
Kind of
And the way this all evolved, it was convenient for us. It was a fairly straight line. We had an on-prem gateway or edge device that was there. And now, kind of progressing, to the right of this diagram here, now we're adding much more intelligence to that on-prem edge device, right? So we continue to push that down. When we first started this, it was, the core thing is it's all about the data, right? The data is the most important asset in all of this. And we were collecting that data since 2015 now. So 10 years of data, but the way we were presenting it back was very traditional in an HMI or a UI. But now with the, availability of AI technologies, we're pushing more and more of that intelligence to the edge. Not everything goes to the edge. I think on an earlier slide, we made the comment, we push the right things to the edge.
Sure.
And that's all driven by resilience, right? These are quite often 24/7 operations, and they need to stay up and running all of the time, whether they have internet connectivity or not. So pushing as much of that to the edge as possible is what we've been doing. You can see kind of what that looks like here in this diagram. And then we still heavily utilize AWS cloud in our architecture, and that kind of top end part of it. And that's used to do things like, the retraining of the model, the collection storage, the portfolio management. For the most part, all of our customers are multi-location. So, having that cloud part of it is an important component to this equally.
Interesting.
And then now we also have that ability to do agent interaction with that too as well.
So not to get too much in the weeds on this, and I know you have more stuff to talk about here, but in terms of agentic AI, are you outfitting these gateways with some sort of MCP server interface so that I could, connect my AI or enterprise AI system to the gateway itself, or is that all through the cloud?
It's right now it's mostly through the cloud, but we're looking at the right places to put that intelligence, right? How much of that do we push to the edge?
Right.
And that, that's usually driven by the needs of the customer at that location.
Yeah. Because right now you can run small language models, multi-billion parameter language models in gateways.
Yes.
Put a kind of a micro MCP interface in there, and then all of a sudden that thing, it's pretty amazing. But
I think, this is where technology is slightly ahead of the capability of an average user, let's say.
Right.
So I think we'll see more and more of that as time progresses, where people are, they kind of go to their phone and they jump on, we have an example here of our Ask eView agent there. When that's available local on-prem, for instance, then it makes much more sense to push more and more of that down to the edge, right?
Yeah. This is probably a great transition time as well to jump into eView IoT Pro and talk a little bit about that, how you make that data available to customers.
Sure.
And in a way that they're able to work with it. Yeah.
Yeah. Sure. Why don't we jump right in? So our latest addition to all of this has been this AI layer and AI capability that we're trying to build throughout the stack here, right? The thing that you see here on the screen, this Ask eView, is a live AI assistant. It's totally connected through the stack with the live data. So for instance, on here, if you can see what's being asked, It's asking very specific real-time questions about a particular location or even zone within that building, right? So you can jump on and say, why is it warm in the dining room? Or, why is the unit not running in the kitchen, or whatever the question might be. So it's actually connected all the way down through the stack. And that's sort of the premise here, is to make this, I think over time here, we're going to see less and less use of traditional UI and more and more use of, this agent-based interactive kind of an interface. People don't need to, my team can go on and read trend graphs and data, in their sleep. It's a little like reading the Matrix, but it's Greek to everybody else. So having the ability to ask, questions in normal English and get responses in the same way back is kind of a key point of this whole thing.
Yeah, awesome use of data and making that available in a meaningful way to, like you said, meet the needs of your users. So it's really awesome to see. And my understanding as well, this is not pulling from like a knowledge base. This is actually interacting with the real system itself, correct?
Yeah, absolutely. So right now we are running things daily and in combination with live data to look at some of the deeper analytics. But yeah, it's all live interaction here at this level.
Yeah. And so beyond the conversational layer that you've built, can we take a look a little bit more about what's underneath the hood?
Sure.
And what's driving, how are you using that data to drive that interaction with the user?
Sure. So one of the tricky parts in this whole platform is the platform serves two different end users, if you will. What you're seeing here is screen captures from the end user in the restaurant, for instance, or an owner, or potentially a facilities maintenance person that's working on a rooftop unit or something. But this view here gives at least some basic information to an owner about their RTUs. Each RTU is scored. The score that you see there is derived from, it starts at 100 and then it goes down from there, depending on what we found for problems, what our platform has found for problems. So that every RTU is scored, every location, when you're looking at a portfolio level, has a score. So now you can start to prioritize things, right? So if I don't know about anyone else on the call, but every customer I've ever worked with never has budget enough to replace all the equipment they need to replace, or to maintain all of the equipment in the way they'd like to maintain it, right? So prioritization and a methodology for doing that was really an important part of what we tried to build into this. And the simplest way, this is a little like your credit score or something, right? Let's give it a score. Let's track it over time so you can kind of see how you're doing. And that's what you're seeing here, is kind of that basic information that we provide, like a in-store or on-prem or in-restaurant staff or owner.
And so along with that prioritization, it sounds like you're also then giving recommendations, right, on what could be done and how that, what the benefit of taking those actions would be.
Yeah, absolutely. And as much as I'd like to say, we identify every problem to 100% confidence, that just doesn't happen. That's not reality. But it does do a pretty good job at identifying the likely causes of the problems and then sort of ranking them in terms of confidence. So an owner can, kind of understand that. And here's another thing. I don't know about anyone else listening here, but every time an HVAC technician showed up at my office, even at my home, and came back with a list of all these problems and all these things that needed to be replaced, there was at least a little part of me that was a little bit doubtful, right? It was like, I didn't, I wasn't that uncomfortable. Why all of a sudden do I have a $5,000, repair bill on my unit? Well, this is all data driven now and gives the user, that, like the owner of a restaurant, for instance, confidence that what they're being told is based in
Right,
data
right.
and so forth. So
There-
that's kind of the hump that we were trying to get over with this basic UI.
Yeah, more transparency. There's a
Yeah.
question here around, you know, you mentioned about kind of the slow failures of some of this equipment. I mean, I assume that there's probably, maybe you don't want it to auto order replacement parts, but probably it can do some proactive, like, you know, heads up, like you said, on some equipment that's sort of underperforming and maybe is heading toward a failure, that you could sort of get ahead of it and get some
Yeah.
parts.
Yeah, I love Michael's forward thinking here. Actually, it's great. So we're not quite there, but we're on the cusp of that. What we are seeing a lot of demand for, and we've done that. We were doing this, well, gosh, maybe almost 10 years ago now. But now it's a whole different ballgame with AI. And that is connection to CMS systems and ticketing, right? So while we might not order the replacement part, certainly can develop the ticket that would drive, you know, a technician call or some, you know, a repair coming out to this.
Right.
So that's sort of the first step, and then it may evolve a little bit further past that.
Cool.
So it's probably a great transition. We kind of zoom out a little bit from a single unit to the whole portfolio. Can you walk us through what a facility manager operations lead is looking at on this slide here?
Sure. So this is the what I'd call the AI portion of the platform, or the AI layer that you're looking at. This is not a view that somebody would see, you know, in store. That 20-year-old I was talking about is not looking at these screens. This is owner level or facilities level type of a user interface here. And the first screen on the left that you're looking at shows results from their entire portfolio. And what you can see there are, it's identified which locations need immediate action, which locations we're monitoring because there's some suboptimal performance happening in those locations, and then which locations are fine and they don't need to worry about. We're even tracking which locations aren't communicating right now for whatever reason. And there's always, you know, a small percentage in a portfolio that end up there. Each of these locations, now you can see, has a score. So now you can use that information in really novel ways, like I have a limited capital budget, like I mentioned before. Which locations should I focus on, you know, maybe replacing some of those RTUs, or which RTUs should I replace, right? So that scoring system is kind of an important part. And on the right, you can see that screen is, once you've clicked into a location, you can see the detailed data coming forth on that location. Each RTU is now scored. And so now you can really dig into, okay, where do I need to spend my maintenance dollars? You know, do I really need to replace this unit or not replace this unit? And, you know, as you go deeper into those screens, the data and information gets much more useful for a technician who's looking at this and getting ready to come out to do a repair.
Yeah. One of the things that people may not realize about Edge AI is that, especially adding language models into the Edge, is that you can add a lot of simplicity over complexity, right? So we have these systems that have lots of sensor data, lots of cool dashboards and data like this. But like you said, overlaying some language models on top of it can actually, you can, with your other interface, like you said, query some of that stuff in more of a natural language and sort of get the gist of what's going on, as opposed to, you know, digging into the details. So that's an incredible example of where, you know, generative Edge AI really can shine.
Yeah, absolutely. And you can see that ASCII view is available here. And just like on the previous screen where the on-prem users might ask, why am I hot in the kitchen? Or why am I cold in the dining room? A technician would get on at this level and start diving into the specific problems that were identified.
Right, exactly. Cool.
Yeah.
So, and this is supported both by our trained data and live data, as well as general knowledge AI also on there, right? So kind of combining both of those worlds as well.
And can you walk us a little bit more through some of those, maybe a scenario, the full picture from fault detection through what the recommended actions were that were taken? And again, just diving a little bit into how you facilitate that with the data that you've accumulated over the years.
Sure. That's a great direction here. So as we're collecting data, we're trying to make that data and information available to technicians with more insight of what the problem actually is, rather than them have to go diagnose it right live. We do this over time as we go into this, and a big part of this is, once we've identified the particular issue or problem, and here you're seeing a checklist for maintenance. You're also seeing, a report here about what is working properly. You see the trend lines, the specific problems our models identified. We're very transparent, and this right now for us especially, this is very much about learning and continuing the learning and training of this whole system. So you can see where our agents agree or disagree on this model, and we provide that back. And then the other part that's not obvious on this, but we do have the ability to then, let's say a technician sees the problem, identifies, the likely issue that they need to address once they're on site. They come out, confirm the diagnosis, do the repair, and then the invoice or ticket that they, the service ticket that they write up, we now are starting to ingest those back into the system to close the loop on what our AI predicted or assumed or inferred was the issue, and what the technician actually found. And we can do that by scanning invoices, documents. We have a capability built onto the screen here where we can actually manually enter that information in. So that's become a very important part of our ongoing continuous learning and training of the model. So the more and more of that we collect, the higher the confidence levels are in our diagnosis, and the better this system is actually performing.
Cool.
Awesome. I can imagine making that easy for your customers is really key, because if it's difficult to do, they won't help you close that loop. So
that's true. It's true. And ultimately what we want to do for the end user customers is try to avoid these issues, right? Altogether. And that's, where we tend to focus on, here are the locations that, and on any given portfolio, it's somewhere between 5 and 10% of locations have action needed immediately, right? Something, a unit is actually blowing warm air instead of cold air, for instance. But a much larger percentage, twice that, are locations that are being monitored, right? So the system identifies issues before the owners even know there are problems. That's where we're starting to really focus in on catching the problems and being proactive about the maintenance. It's much better to have a proactive service call that you schedule than a 2 a.m. call, that's an emergency in the middle of the night. That's going to cost you, 3 to 5 times more at that point in time. And not only the cost of the repair, but now you've done, much more damage to the unit. You've affected its overall life cycle and how long it will last. All of those things we're trying to really prevent. So for our end user customers, we don't even want them to have to ever know about this part of it, right? Ideally, we want to be much more proactive and out in front of that.
And it's quite impressive, the longevity of your company and the products that you've offered in the market and the data that you've collected over time. And you have some really interesting, staggering statistics about how predictive, operation, it isn't theoretical, right? How you've used your data to make it actionable. So can you tell us a little bit more about some of those metrics and things that you've derived?
Sure. So the big one here, the ROI, the payback, I should say, in less than 18 months. Doing a basic intelligent energy management system on most of these locations, at least the way that we've done it now, achieves this less than 18 months already, right? If you now add to that our capability of keeping units up and running and add back that savings, this becomes much, much shorter, half or more in time of payback. You can imagine, we're talking primarily about rooftops, but we're applying the same model and capability now to walk-in refrigeration units. And if you can identify an issue with your walk-in, and you're a high-end steak place, let's say, or a seafood restaurant, and you're typically storing anywhere from $20,000 or above in inventory in those walk-ins, if you can prevent even one loss, that more than pays for the system immediately, right?
Yeah.
So
definitely.
that the idea that we're out in front of the problems and being proactive and identifying them before they become an emergency is really the important part of this thing, right?
I was going to say the other thing that I was curious about here with this data is, I guess in some environments, you were talking about Europe earlier, you're in Chandler where it's like 110, 112 degrees. Sometimes the local utility companies will be like, can everyone sort of dial it down a little bit, or, or you might want to optimize for peak demand management and stuff. I mean, I assume that this kind of system could kind of pretty automatically across multiple locations kind of manage that, right?
Most locations that are commercial businesses like this, especially what I'd call the working buildings, not office buildings, but restaurants, convenience stores, supermarkets, very often pay more in demand charges than they do in their actual electrical consumption, right? And that happens for a number of reasons. A hot day, like you mentioned, in Arizona, people are running their ACs, and they're running all of them. Even a typical little McDonald's, let's say, might have 5 rooftop units, and all of them are going on and off all day. And most of the time, the kitchen one or kitchen units are running, from the moment the sun comes up until the sun goes down, right? So that is an important part of this whole thing. But the peak demand part of it really can layer on extra costs to an owner. And we've actually partnered with a company called Leap to do peak demand management in states where that's available, right? So that's an extra incentive from the utility. They send out a signal ahead of time. Our system reacts, does some different things to sort of use the building and its thermal momentum to carry them through, and then manage how many rooftops are running at any given point in time. Just nominally, when we deploy and set things up, we don't have control over all the kitchen equipment, but we have control over the rooftop units and the lighting in particular. And we will even just initialize their scheduling so that they're not all coming on in the same 15-minute time to help avoid that peak that you were talking.
And that's exactly the kind of thing that, no offense to 20-year-olds, you don't want to ask the 20-year-old to manage any of that stuff, right? That's all. And especially across multiple locations, right? You want to kind of do that globally.
Interesting historical story, working with big restaurant chains. All of the big franchisors have startup schedules that are recommended best practices. Some of them enforce those in different ways. But inevitably, what we see is the majority of managers who come into, let's say, a quick serve restaurant, they're firing up all of the equipment all at the same time, turning the switches on. And somebody explained that in their defense. Somebody explained that to me. And manager said, listen, you only have to miss being able to deliver food at the right time. Let's say you're firing up for breakfast or lunchtime once, and you'll never forget to turn that equipment on again. Right. So now, as a defensive measure, they fire it up when they get in there, and then they're ready to go no matter what happens. Right. So the equipment we have, not so much in the food prep, area. So we're a little bit more secondary to that. So we have a little bit more control, and we can do something about that. So.
And I assume over time, you mentioned some of the legacy equipment. Eventually, as that legacy equipment gets replaced, it's smarter and smarter, and you'll get more data and more control over more equipment in kind of these systems, right?
Yeah, absolutely. When we started, every location that we went in to do refrigeration smart or intelligent refrigeration control, we were adding the controller. Now we show up in a very large measurable percentage of owners have equipment with that same OEM version of what we use installed on the equipment already.
Nice.
Right.
Yeah.
So it is that, and that's the same thing I mentioned earlier. Companies are pushing the intelligence and capability more and more to the edge.
Right. Yeah. Some people might not realize when you go and do brownfield deployments of things, sometimes you're just measuring current, and it's like, that's the only signal you have is current. And you have to infer all kinds of things from that. So it's cool to see this equipment now getting, in many cases, not only kind of the measurement capabilities, but even its own ability to run ML and AI models in the equipment itself too, which then gets coordinated through gateways and other architecture. So we're seeing multiple AI models from the far edge to the cloud, right? Which is
absolutely. And and that's one thing that edge AI is great at, is that on-prem inference, even of just a current signal, you can get a lot of inferred information out of just a current signal. Is the store open or closed?
Yeah.
How long did that compressor run or didn't run? Right. So you can, and then you can turn that into what was the predicted energy consumption, right? If I know how long a compressor runs and I have the nameplate information on that, I can tell you pretty close, how much that should be consuming. And then when it's not, you have an issue, right?
Yeah.
So
interesting.
You're right. You hit the nail on the head, though. That inference, even the simple signal, it's really it's a whole different game these days, right?
Yeah, which I think again, just your perspective and the long your long history working in this particular segment, you've clearly learned a lot of lessons. You're probably still learning, especially with the availability of AI and making those determinations, on the edge versus the cloud. Can you talk a little bit more about some of those lessons that you've learned, and any advice you have for the audience that's listening?
Sure. And I've touched on several of these already, but one of the things that we learned right away is you got to survive disconnection, right? Everything's got to work. A thermostat's got to be a thermostat, whether it's connected or not. Same with lights, have got to go on and off, whether they're connected or not connected. So you have to really think all the way from not the typical edge controller, but the end point device, right? And then work your way back. So surviving that is one of the most important things. Model retraining and continuous learning, since we've moved into the age of AI, is critically important. Making these things better, more accurate. It only takes one highly confident false positive to really lose confidence with end users. So that's a really big deal for us. And that's really non-negotiable, as we put here. We learned pretty quickly, not everything belongs at the edge, right? So you have to sort out what does belong at the edge and what it doesn't matter. It's non-real time, or it can wait, or it's needed to be in the cloud to handle things like portfolio management, right? And then the last point on here is that multi-tenant from day one. That was all about, our origin story, working with large chains. That was the way we architected things from the very beginning, right? And it's much more common to have a chain of buildings or a portfolio of buildings that are SMB buildings, as opposed to, other than applications like a university campus, for instance, where there's lots of buildings and you've got a portfolio of buildings that you're managing. Everything in our world was a portfolio in the beginning. Sometimes that portfolio was 5 locations, and sometimes that was 1,000 locations, right? So you had to be ready for all of that.
Yeah. Really cool. I had a couple of questions too, and I'll invite folks on the on the show here to throw their questions into the hopper. I know Cal's asking about slides. So the whole thing is going to be on YouTube. That's kind of our vehicle for reviewing things. So watch the YouTube at your leisure. But I was going to ask Tracy, one of the things we've been looking at the foundation and the community is around standards. And, as Edge AI becomes more mainstream and more mature, like, how do you see standards helping your business, or where would you see the need for more standardization to sort of accelerate your business? Like, what's your perspective on that?
So standards is something near and dear to my heart. I have been the chairman of Lawnmark International Trade Association for 20 years. One of the original building automation networking technologies, right? Now it's it's kind of on its tail end and been replaced largely by BACnet, which we are also very active in. And then I'm also on the board of the Coalition for Smarter Buildings. And in that coalition, for instance, we are all about creating standards, and not physical layer standards, but semantic standards. We're working with NIST and ASHRAE to develop those standards. And for us, we understand our customer base and the locations that we've been connecting to for years. We don't need that to be, standard semantic data. But for us to scale and grow, for us to open up new markets, for other companies to innovate using AI, those standards are incredibly important in doing that. Making semantic interoperability is kind of the goal here of a large part of what we're working on C4SB. And by the way, I don't believe AI will scale in the way we'd like to see it scale in this market if we don't get to that point. This market, quite honestly, has been held back and delayed for decades because of all the proprietary walled gardens that manufacturers have created around their ecosystems. And the only way to get to scalability, true interoperability, a sustainable competitive environment is to get to standards and at this point with AI, semantic interoperability.
Yeah, great.
Personal opinion there.
No, it's good.
I'll get off my soapbox for a minute.
I hear you. We do have a question from John here around sensor data. Do you have any challenges with sensor data bandwidth to the cloud? If so, how do you mitigate that? And maybe the sensor data is processed locally, but I'll let you address.
Yes, there's a couple of strategies. You just named one of them, right? With more and more intelligence and processing capability at the edge, we can process that locally and focus on the exceptions in the data sets, as opposed to pushing every single point to the cloud, right? The other thing that we've done in lieu of that, and for cost reasons, maybe as much as anything, is we also can scale back the amount of, we have control over how much data we're pushing to the cloud. So we have customers that we've worked with. They had an absolute need to have data points every second in this particular device that we were monitoring for them. So in that case, we had to pull that data that fast, right? Whether it be queuing it locally and then synchronizing as possible, or just better, bigger pipes, for instance. While other data like room temp data, you don't need to know the temperature in the room every second, right? Every minute is still a little overkill, and every 5 minutes is probably pretty good, right? You think about things that can affect room temp, like door openings and stuff like that. 5 minutes, you wouldn't want to go much beyond that. Power, utilities typically look at power every 15 minutes, for instance. So there is some ability to scale that. So not every sensor is created equal. And looking at how much of that and how much you want to bring to the cloud as opposed to processing it locally is part of the strategy for sure.
Yeah, for sure. And I think also the fact is that now that we're in a new era edge AI, I mean, I would characterize sort of the embedded systems era from decades ago of being disconnected compute to IoT, which is, kind of dumb sensors sending everything to the cloud, which was challenging.
Yeah.
So now, now we can mitigate connectivity cost and issues by processing things more locally and in more real time. So
yeah, absolutely.
That's another advantage of edge AI.
Yeah, I'm sure. I don't think it's a secret to say that, one of our long-term strategies is to make every building autonomous or self-sufficient in every way possible, right?
Right.
So, we're working with some engineering companies on some of our work, on some of the most intelligent buildings in the world, and they're making them, capable of being completely off grid, kind of that zero carbon footprint. And to do that, it has to have a certain amount of capability on-prem to diagnose, understand things, take corrective actions before they become bigger problems, right?
Right.
So
exactly.
Yeah, that's
Cool.
all part of it.
Wow. Well, Tracy, I learned a lot. So I appreciate all the time that you spent kind of educating us and the audience on this stuff. And like I said, it'll live on forever on YouTube. So people can get that education there. And Jennifer, I don't know if you have any closing thoughts or.
Just awesome information. Love the contribution to sustainability and the impact that this is going to have longer term. So great to see how the technology is enabling it. Thank you so much, Tracy.
Fantastic.
Yeah, I know, and I appreciate it. I appreciate the time here. We're trying to make existing buildings and existing hardware smarter, not replace all that. I see some more good questions coming up from the crowd.
Yes.
I'm happy to address them or answer them. I don't know if they have the ability to send those in, but
yeah, I think you can actually address them on LinkedIn probably.
Okay.
But we can do that. There's always some good questions.
Yeah, and just that one that just popped up, there is a SaaS component to what we do for sure.
Yeah. Okay.
So, yeah.
Good. Awesome. Well, Tracy, stay cool down there. And really appreciate
stay
it.
Inside then, right?
Yeah.
That's right. Stay inside. All
Yeah.
right. Thanks, everybody.
Thank you, Pete.
Thank you, Tracy. Thank you, Pete.
Yeah. Bye.